In these examples, we'll look at some logic-based questions utilizing dimensional analysis as our approach. Example number 1 asks, a patient currently weighing 250 pounds is asked to lose 10 pounds in preparation for surgery. After 5 weeks, they're brought back and weighed again, this time weighing in at 108 kilograms. The question is, did the patient meet the weight loss goal? In this case, we'll need to start by converting to something that we can compare to our weight loss goal. So we need them to lose 10 pounds. Well, let's start again with our desired metric of pounds. We know that they currently weigh 108 kilograms. And the conversion from kilograms to pounds is again that 1 kilogram is equivalent to 2.2 pounds. When we make the calculation here, we'll find that the individual now weighs 237.6 pounds. So did we meet our weight loss goal? Well, if we take the difference here of 10 pounds, we should find that as long as they're under 240, then yes, they've met their goal. So in this case, yes, we have met our weight loss goal for the surgery. Example number 2, we have a child weighing 55 pounds who is receiving 0.05 milligrams of medication per kilogram of body weight for every dose. So how many milligrams does the patient receive per dose? So again, we want to understand the number of milligrams per dose that are being given. And we have, to begin with, the weight of the patient, so 55 pounds. We'll convert this, again, as we usually do, to kilograms, so 1 kilogram for every 2.2 pounds. The next conversion we'll need to make is the given metric here of 0.05 milligrams per kilogram per dose. So the way that we'll write this out is 0.05 milligrams in the numerator, and we'll have per kilogram per dose in the denominator. So looking at our units here as they cancel out, what we'll find is that the first computation converts to kilograms. When we multiply our kilograms together, we'll end up with our milligrams per dose as desired. So we have our units canceling appropriately. When we do this computation, we get 55 times 0.05 in the numerator, and dividing that amount by 2.2 should give us a solution of 1.25 milligrams for every dose. For our last example, we have infant formula available in quart containers. And it says if an infant usually takes 4 fluid ounces every 3 hours, how many containers are going to be needed for 3 days? So one of the conversions that we'll need to know here or be able to utilize is that 1 quart is equivalent to 32 fluid ounces. So in this case, we can utilize, again, the idea that we're interested in the number of containers at the end. What do we know? Well, we start with 4 fluid ounces being given every 3 hours. Now, the conversion here can be made in a couple different ways. We know that, for instance, 1 quart is given every 32 fluid ounces. So that's a conversion that will give us the measure of quarts per hour. But we don't want it per hour. We want to know for 3 days. So in this case, we can then convert by utilizing the size of the container. So 1 quart is a container's worth. this instance, we have 24 hours every day, but we want to know for 3 days how long that we'll need for this particular computation. So that should give us the containers necessary for those 3 days. Now, it's not a division here, I should say, really, that our day unit here will cancel. So we have hours canceling, and since 1 quart is the equivalent of a containers, we might say that we do end up with the appropriate unit here. So the computation here will cancel out the 3 over 3. We get 4 over 32 is the same as 1 over 8 in this case. So 24 divided by 8, essentially. We should find that we need 3 containers for the 3 days. So essentially 1 container a day is how this works out.